All right, good morning, everybody. Happy Thursday to everybody out there. I want to thank you all for joining us today for our fifth tech webinar this year. My name is Anthony Connors, and I'm the Regional Field Engineer for the Michigan and Toledo area, and I'm going to be your host for today. Real quickly, I'm just going to go over a couple things you might be noticing here. If you're new to these types of events, you probably have already noticed this, but your camera and microphone have been turned off. And hopefully on the right side of your screen, you should be seeing a handy Q&A feature. If you have any questions that come up during the presentation, you can feel free to submit them there with your first and last name as the presentation's going on, and we're going to take some time at the end to answer your questions. If for some reason that doesn't seem to be working for you, you can always email your questions to solutions.michigan@swedgelock.com, and we'll add your question to those for our presenter. But with that out of the way, I would now like to welcome Jamie Stiglish for joining us today. Jamie is a mechanical engineer graduating from Michigan State just over 1 year ago, before joining our SwageLock team as our custom solutions project manager, and she's going to be taking us through a webinar today on the S.T.A.M.P.E.D method. So without further ado, I'll now turn it over to Jamie.
Hey, thanks, Anthony. Good morning, everyone, and welcome back to our next webinar. I'm really excited to be talking to you guys today, and I hope everyone can take something new that they learned out of this webinar. So starting off, what is the S.T.A.M.P.E.D method? Well, the S.T.A.M.P.E.D method is an acronym used to aid in selecting your appropriate product for your certain application. When should it be used, you may ask? Well, it should be used both during your design process as well as during installation. The S.T.A.M.P.E.D method is really important because it ensures proper selection of product, which is beneficial to your personal safety as well as safety of the system's performance, and overall system compatibility. So as we go through this presentation, we'll take a deeper look into what each letter means and why it's so important. One thing to know is originally the S.T.A.M.P.E.D method was created for the hose selection, but can also be applied to other product selection, such as valve and tubing. So the first letter in the S.T.A.M.P.E.D acronym is S, which stands for size. So you may ask yourself, what information do I need to know before making an order? What should I have ready, and what questions do I need to bring up to my account rep? Some good questions to ask yourself and to address may be, what's the inner diameter or outer diameter needed? If you're purchasing a hose, what live length do you need overall? Ultimately, the answers to these questions will lead back to what flow you need. Going forward, we will discuss the flow and how it impacts the system. Then we can take our flow and back calculate to determine what size diameter we need. Bear in mind that SwageLock offers hoses in nominal diameters of an 1/8 inch to 2 inch, and most everything else is offered in nominal diameters of a 1/16 to 2 inch. Remember, when we're dealing with tubing, we're calling out the outer diameter. Conversely, if we're dealing with pipe, we'd be calling out the inner diameter. So say you need to match tubing to 1/2 inch parts, you would select a 1/2 inch OD for your tubing. Another thing to remember is the size of the tubing you need is always going to relate back to the flow in the system. Flow is what drives the size tubing you need and drives much of the selection of any product we offer. So if you're questioning your choice when you're selecting your product, know that we're here to help and we're happy to do so. So jumping back to the main idea of size, it's important to consider the amount of space you have to work with. To combat lack of space, try to choose something that's boundless. For example, a hose assembly with elbows and union ball joints would provide more room as opposed to a hose with MPT components. Now, while MPT is great for some applications, it can limit your movement in space due to its non-swivel characteristic. Like I mentioned earlier, flow is a very important factor that is affected by size. And the same breath, volume is important too. Again, if you are purchasing tubing, think about that desired flow and choose the diameter that will support the flow. The reality of it is to calculate the appropriate inside diameter and area that you need for your flow. So if you've got 1/2 inch parts, you'll match to 1/2 inch tubing, but what wall thickness do you need? What really drives your wall thickness is the pressure you need to contain and the strength the tubing has to have. Now, if you're purchasing a hose, it's important to ensure the hose diameter and length can supply enough flow for the application. Keep in mind that bend radius of your hose. So if your bend radius is too tight, the system will experience restricted flow through kinking. There's also the possibility of overflex. And lastly, when you're choosing the correct length for your hose, keep in mind any effects of movement. Once again, flow is largely affected by size. I really want to hammer this in, so you always think flow, flow, flow. In terms of valves, flow is largely affected by your flow coefficient, or CV, calculation, therefore your orifice size. Think about the CV as the capacity of the valve. Anyways, when selecting a valve, when you're looking at your pressure drop that you want to tolerate, we want to determine if that valve is capable of doing what you need it to do. And CV is the heart of that. Keep in mind that you don't want to oversize or undersize the valve you choose. Undersizing can lead to not enough flow, not enough volume. You may experience excessively high pressure drop, which will result in not enough pressure at the end of your line. Conversely, oversizing is the opposite. Oversizing can lead to your fluid flowing very slowly at a low velocity, so this can cause low to no turbulence. If you have any mixed media in that, it can drop out and you can get plug up. There's also the possibility of excessive cycling and difficulty controlling at low ranges. The second letter in the acronym stands for temperature. So it's imperative to determine your min and max temperature for the hose, tube, or valve that you choose. You also want to keep in mind the system media and your surrounding environment. The table shown illustrates the working pressure of one of our 60 series ball valves at different temperatures. So if you take a peek, you can see that as temperature increases, the pressure rating decreases. This effect is known as derating. It is like, in this specific case, elastomers in the valve can get softer at higher temperatures, so it won't hold as much pressure. And while we're on the topic of elastomers, one thing to keep in mind is that while softer materials can make better seals than rigid ones, rigid materials will be better at your high temps. So a soft material at high temperatures may be compromising your system. Therefore, the value of our rigid materials at higher temperature applications is a great option. Next, we'll talk about applications as they pertain to the S.T.A.M.P.E.D method. Something to consider in terms of your hose application is if your system is static or dynamic. A static application is a system that contains no movement as part of its function, so a regulator panel coming off of a tank. A dynamic application is something that has motion to it. So for example, a tire press machine. If you do have a dynamic system, you want to stay away from metal cores because those can crack and cause leaks. So because of this, you always want to think about both the sleeve and core of the hose when you're choosing the correct one for your application. Again, note that bend radius you need. If it's too tight, you can cause the hose to kink. For the valve applications, think about your CV, pressure rates, flow direction, and what type of valve you'll need. So do you need a needle valve, ball valve, diaphragm? And for more information on valve applications, you can refer back to our last webinar on valve selection. For regulator applications, you too want to think about that CV and pressure rate. Also decide if you need a back pressure regulator or reducing regulator. Should it be single stage, two stage? And lastly, if you are working at a low pressure, how accurate do you need to reduce it to? For more information on regulator applications, you can tune into our next webinar, which will discuss regulator selection. Again, we're always here to help with your selection, so if you have any questions, don't be afraid to ask. Next, we'll go over material. So to choose the correct material, you want to consider the media and environment the product will be exposed to. Some questions you might want to ask yourself are there wetted components in the system? This is something you really want to focus on because you want to consider looking at your material, chemical, and temperature compatibility charts. Remember that a wetted component is anything your fluid touches. So you can do your stem packing, diaphragms, poppets, and if you take a peek to the right, you'll see an exploded view of our 60 series valve, along with a table listing its materials of construction. So if you look at that table, you'll notice all the wetted components are in italics. This is something Swagelok does to all of its products and can be found in our catalog. So this is kind of a neat trick because it can be helpful in determining what components you need to look at for your material compatibility analysis. Another thing you want to ask yourself is if there's a possibility of corrosion. If there is, you might want to consider looking into the alloys we offer. For more information on wetted components, you can look back to our previous webinar. The next letter we'll look at is P for pressure. When selecting a product, you want to identify the min and max pressure the system will undergo. So think about your normal operating pressure as well as extremes in both directions. What will the highest pressure be at your highest temperature and vice versa? Also think about the working pressure of the product compared to its burst pressure. Then you can choose which product is best suited for your system. Again, know that derating is possible, so if your temperature increases, the pressure rating will decrease. Now we'll discuss our end connections. Identifying the type of end connection you need is very vital to the ease of use and system compatibility. Along with your main component, the end connections also have pressure ratings that can differ in materials, so selecting your correct end connection is almost just as important as selecting the correct component. One of the great things with our end connections is if space is a concern, just change it. Make sure you select the end connection that is going to be best suited for your application. For example, M.P.E.D might not be the right selection if you are lacking in space because it doesn't allow for swivel. So instead, try using a tube adapter. Tube adapters are nice because they're the most readily available for our hoses, and they can adapt to whatever else you need. For example, if both of the ends of the hose are stationary, it can be hard to install and perform maintenance checks on, so tube adapters are nice. For our valves, the end connections that are most readily available are female and PT. You can also get VCO or VCR ends, which are really nice for certain applications. And some of our oddball ones we have are male pipe on one side and female pipe on the other. We also offer butt weld ends, and our 60 series valves are great for butt weld ends because they're exceptional for welding in place. If you want to know why they're so great, you can jump back to our last webinar. So as you can see, there's all sorts of options and things that you can do to get the correct end connection that can meet your goals. Overall, just think about how you are connecting these to your system. Is it just for your initial install, or will you need to perform maintenance checks over time? If you do, think about how long you're disconnecting these or how frequently. If you disconnect them a lot, then you might want to opt for a quick connect end as opposed to M.P.E.D. And also think about your clearance. So you want to compensate for that. The last letter in the acronym is D for delivery. So in terms of delivery, how fast do you need it? If time is of the essence, then you might want to make a small change to your part or BOM to get a shorter lead time. If you run across this, our sales and engineering team are skilled in finding alternate solutions. So for example, we can combine multiple parts to replace the component that has that long lead time. If you plan on ordering parts frequently, a stocking program might be right for you, or even a blanketing program. Say you need exotic materials, you want to make sure that you do plan ahead on those. And just know that we're here to offer your supply chain solutions to meet your long-term needs. So if any of these programs interest you, go ahead and talk to your account rep about your options. Also note that we do have in-house capabilities. So these can range from making hoses, performing nut and ferrule changes, setting relief valves, bending tubing, and even pre-swaging nut and ferrules on for you. So if you are lacking some time, we can take care of that. One thing we also offer for delivery is if you need special tagging or packaging. So think about in terms of tagging, this can be as simple as a part number that we put on. We can include your PO, manufacturing date, or sequence number, and we can also mark the outside of boxes. So say you get 5 boxes of component X, and they all need to go to separate locations in your facility. We can mark those 1, 2, 3, 4, 5, and that can make it easier on the incoming side, as well as helping your operators determine where those parts belong. Another thing to think about for delivery is, do you want the products individually packed or bulk packed? If you do like them individually packed, that can be much easier for stocking them, but just know it creates a lot of plastic waste. One thing I do want to touch on is, addition to the S.T.A.M.P.E.D method, cleanliness is another aspect we want to think about. So is standard cleaning going to be sufficient for you, or does your system require special cleaning? Swagelok's standard cleaning cleans our components to remove oil, grease, and loose particles, and then after the products are finished, they're packed to protect them from any contamination or damage during shipping and storage. In addition, any exposed mail threads will be capped. But if your system does need a little more help, Swagelok's special cleaning uses oxygen-enriched environments for packaging. And note that when you do get those components, you don't want to open them until you're ready to use them. So before we say goodbye, I'd like to run through a quick example of how to use the stamped method and show you just how easy it can be. So the picture to the right is a cylinder, and that will be our target, and say we want to replace the valve on it. So first we have to determine the size. After measuring, we can conclude that the size is going to be a 1/4 inch. And for this system, the temperature will be about 200 degrees Fahrenheit. Moving on to A for application. The application under question is a sampling system with a needle valve. So in this case, I really want to specify that the needle valve is our best choice. Using a needle valve will allow you more metering control and can prevent any pressure surges that you would get or experience if you were to choose a ball valve. The media going through the system will be sour gas application, and the desired pressure will be 75 psi. So for end connections, before we did measure 1/4 inch for the size, so we're going to do 1/4 inch male MPT. Lastly, for delivery, let's say we're going to do 4 weeks. So as a customer, this is something you want to request the product to arrive at your facility, starting from the time you place the PO. So if you want 4 weeks, then we'll give it to you in 4 weeks. And based on all this information, we're going to select this valve here. And moving on, if you look at this table, circled in green, you'll see that the temperature of 200 degrees Fahrenheit allows for enough pressure rating at that required range. In terms of end connections, you'll note that this table has male NPT connection, and it has the correct CV calculation that we need. So following that across to the end, you'll find the ordering number for the valve. However, we do have to slightly manipulate this because it is a sour gas application. So we have to choose that designator -SG at the end. And lastly, at the bottom here, you'll see the final part number for the valve. And once all this information has been determined, we can then take that valve and order it and put it on a PO. And this specific valve will be available in 1 to 2 days. So to review, what is the S.T.A.M.P.E.D method? Well, it's an acronym that we used to select the appropriate components in our fluid system. When should it be used? Both during planning, installation, and/or maintenance. And why should you use it? To assure all of your fluids are flowing as you intended them to. So hopefully this webinar was helpful and you took something away from it. Now we're going to move on to questions.
Awesome. Thank you, Jamie. Yeah, as she had mentioned, we're going to take some time here and answer some of the questions we have. Looks like we have a good amount, but I do want to remind you that if you do have any, you can always use the Q&A feature on the right side of your screen with your name, and we're going to add your list for our presenter here. So with that, we're going to roll in. Jamie, first question here looks like it's from Kevin, and Kevin's asking, when should I use carbon-filled cores for hose?
Okay, it's a good question. So carbon-filled cores would be a great choice if your system is experiencing any kind of static. Static can build in your system through the friction caused by your moving fluid. So a lot of the times with hoses, that static tends to eventually find a way out, but it can rupture through the hose. So choosing that carbon-filled, or that, so when you have a carbon-filled hose, you want to make sure that it will work well if you're experiencing any static.
Yeah, great point. Next question, looks like we have a pre-submitted one here. Thank you for using that feature. This question's a bit of a doozy, and we got, during the past few years, we have seen the effects of static buildup on flex lines. In some cases, we have been able to correct the issue by using static dissipated flex line material, just kind of like how we mentioned the carbon-filled core. But sometimes that does not eliminate the issues. Mostly the issue with static buildup becomes evident on noisy feedback signals from sensitive instrumentation. In some cases, static discharges can cause permanent damage, instrumentation, or data acquisition systems. What has been your experience with this issue? So that is very interesting and very specific case here. Like we had kind of just mentioned, if you're using flex lines, you always want to try to stick with the carbon-filled core. That's going to probably help you dissipate a lot of that static buildup, and it sounds like you're already doing that. Another option you might want to look into is running some grounding wire as well along your lines, and that'll hopefully transfer and move your static away from your instrumentation then. Best case, I would also recommend recommend trying to reach out to your account manager, and we can try to see if we can get you lined up with the correct solution there for your problem. And hopefully we can stop you from getting these issues. So moving on here, Jamie, looks like the next question is from Liam, and Liam's asking, do you have products specifically for high temps?
All right, yeah. We offer different metal types and elastomers for high temp applications. So a good example of this would be switching from a PTFE seat material where your temperature maxes out at about 150 degrees to say an alloy, let's say X750. So those can reach up to 450 degrees. We also have valves that are compatible for high temps, and an indication of a product that is compatible for high temp applications will have a -HT at the end. So the best bet is if you're concerned about high temp applications, just reach out to us.
Yep, exactly. All comes down to your product selection, which hopefully you can use the stamp method for. Next question here is from Ty, and Ty's asking, do different grades of stainless or carbon steels need to be used with the same material fittings?
Different grades of materials are usually fine, but you don't want to be doing that with intermixing different materials. So say you don't want to do brass with stainless or copper with Hastelloy. So the best reason to explain why is because the metals are going to have different material compatibilities. So they'll differ in some molecular composition, and that can affect the system.
Yep, good point. Next question we have here is from Owen, and Owen is asking or saying, our hoses fail from time to time. I always assumed it was normal wear and tear, but are we just using the wrong hose?
That'll all depend. First, you want to determine how often periodically is. For some people, it's 3 weeks, but others, it can be 6 months. Generally, my rule of thumb is you should at least be getting 6 to 8 months out of each hose before you should even start thinking about switching it out. Obviously, this can be varying depending on the application. So again, just reach out to us if you're concerned.
Yeah, it's definitely important for hoses, since they are a wear and tear item, that you have some sort of preventative maintenance program in place. We can also help you with that by doing a hose advisory and making sure that your hose selection is right for the application that you're using it for. And it looks like we have one last question here from Matt, and Matt's asking, can we get labels on both sides of the hose? We order some really long ones, and it would be nice to have it on both ends.
Yeah, of course. Any tagging that would make things easier is something that we can do. So along with the normal blue tape tags, we could also install etched metal tags onto your products. And those are pretty nice because it's unlikely for them to wear or fade over time. And again, those can be connected to both ends.
Yep, exactly. One of the things that I do want to point out here too is hopefully you're not using an excessively long hose here as well. At some point, you do want to have some sort of split in between that'll help kind of junction off, and you'll be using shorter hoses at that point. But obviously, if you're just looking to have labels on both sides just for visual representation, that's not a problem for us to do. But with that, it looks like we are out of questions here, Jamie. So thank you all for everybody who entered questions. Looks like we got through all of them here, but just a couple of things to end on. So after the webinar here, we're going to present to you with follow-up email with just a couple of reference materials, one specifically tied towards hose and the other tied towards valves. I'm hoping these will help with your stamped method selection needs. And as always, we're always available to schedule a virtual meeting now with our field engineering team, and you can do that at michigan.swagelok.com. And also want to remind everybody that we're going to try to tackle the regulator basics and selection methods next month for our tech webinar. That webinar will be on June 17th, 2020, and we'll be getting started at 10 a.m. again. And thank you all for joining us again today. If you have any questions, concerns, or feedback regarding the webinar, you can always email us at solutions.michigan@swagelok.com. And again, thank you. And for more information about our webinars, you can always visit our website at michigan.swedgelock.com. Thank you all and have a great rest of the day.